So automation, it's a word that gets thrown around all the time, right? But what does it really mean to take it to the next level? We're going beyond just simple scripts today. We're going to explore how Python is building the very backbone of intelligent, autonomous systems. Okay, let's dive in and map out this whole journey from a single line of code to a system that can practically think for itself.
Okay, let's be real, we've all lived on the left side of this screen. That endless, soul-crushing loop of copy, paste, click. It's not just slow, it's where mistakes creep in. The real magic of automation, especially with a language like Python, is all about getting us over to the right, to a world where these complex processes are just handled flawlessly every single time by a script that never gets tired and never gets bored.
And that right there, that's the whole point of what we're talking about today. Writing that first script, it feels like you've unlocked a superpower, doesn't it? But, and this is the key, true advanced automation is a journey. That first script is just page one of a much, much bigger story.
So let's start at the beginning, where everybody starts, with that one single, incredibly useful script that solves a very specific, very annoying problem.
All right, so here's our ground zero. Think about a super simple script, maybe just a few lines using Python's Shooter library that automatically backs up your important files. It does one job, it does it well, and it solves a real problem. But here's the catch. It completely depends on you. You have to be there to run it. And that, my friends, is where we start to see the cracks.
And this is the question that changes everything. What happens when that script has to run at 3 a.m.? Or when the amount of data it needs to handle suddenly explodes by 100 times? Our little script, as awesome as it is, still needs a human to kick it off. To really level up, we've got to cut that cord.
And this is exactly how we do it. We start giving our automation a life of its own, a pulse. We're moving away from having to manually press go to a world where our scripts just run themselves, on time, every time.
This slide lays out the evolution perfectly. You start at step 1, right? Manually typing python script.py in your terminal. Then you get a little fancier. You use a library like schedule to say, hey, run this task every day at 2 a.m. But what about when things get really complicated? Like, what if one task has to wait for another one to finish? That's when you graduate to the big leagues, tools like Apache Airflow. These are the orchestrators that manage the whole show, handling failures, retrying tasks, the whole shebang.
I love this quote because it just nails it. We're delegating the boring stuff. We're evolving from a script that needs constant babysitting to a system that just knows when to act. It's like having a perfectly trained butler. It sees what needs to be done, waits for the right moment, and just handles it. You don't have to ask every single time.
Okay, so our scripts can run on their own now. Awesome. But where do they fit into the grand scheme of things? Because automation isn't just about fixing one-off tasks anymore. It's literally the engine that drives modern software development, powering what we call the DevOps or CI/CD pipeline.
This flow you see here, this is the heartbeat of modern tech companies. A developer pushes some new code, and instantly automation kicks in. It builds the software. It runs thousands of tests. It packages everything up neatly into a Docker container, and then it deploys it. And Python is right in the middle of all of this, running crucial little scripts that might check a database or verify an API key before that final deployment goes out to the world.
And this whole process isn't some kind of secret sauce hidden away. With tools like GitHub Actions, the entire recipe for this automated pipeline lives right there in a simple file, alongside the code. We call this infrastructure as code, and it's a game changer because it guarantees that every single update is built, tested, and deployed with the exact same level of care. That means getting new features out the door faster and way more reliably. So, up until now, all of our automation has been pretty, dumb. It just follows a strict set of rules we give it. But now, we're about to make the big leap. We're moving from systems that just follow instructions to systems that can actually learn, predict, and take action on their own.
And this is the fundamental difference. Rule-based automation is all about reaction. If server memory goes above 90%, then send an alert. Simple, right? But AI-driven automation, that's proactive. It looks at all the past data and says, based on these trends, this server's memory is probably going to spike in the next hour. Let's shift some work now to prevent that. See the difference? It's about stopping a problem before it even starts.
And what's really wild is that we're using Python to automate the process of creating intelligence itself. Look at this. Libraries like scikit-learn let us build these automated pipelines that grab data, clean it up, train a machine learning model, check how well it did, and then deploy it. By automating this whole life cycle, we can build and update these intelligent systems way faster and more consistently than we ever could by hand.
But, with all this incredible power and intelligence comes a massive responsibility. I mean, an advanced system that you can't rely on isn't just useless, it can be downright dangerous. So the big question is, how do we build systems that we can actually truly trust?
Well, that trust is really built on these 4 key pillars. First up, you need rock-solid error handling, so one little network hiccup doesn't bring the whole thing crashing down. Second, you need effective logging, which is basically a clear paper trail so you can always go back and see exactly what the system did and why. Third, security has to be your top priority, baked in from day one. And finally, and this is so important, human oversight. You have to design these systems to be fault-tolerant and to let a human step in when things go sideways.
So when you boil it all down, this is the main thing to remember. Advanced automation isn't just about going faster or being more efficient. It's about building intelligent systems that are also resilient, transparent, and ultimately deserving of our trust.
And that kind of leaves us with one last big question to think about. We've journeyed from a simple, humble script all the way to a system that can learn and act on its own. As these systems get even more autonomous, moving from just automation to truly intelligent infrastructure, what are the next huge problems we're going to solve? What new frontiers is this tech going to open up for us? I think the journey is really just getting started.